Hey guys, how are you doing today? We're gonna be differentiating the sine function. So right off the bat, pretty much everyone knows that the derivative of sine is equal to cosine of x. But I want to show you why the reason for that is, okay? I mean, you can just say that, oh yeah, sine of x, the derivative just goes to cosine of x. I mean, technically you can, but math is all about understanding, okay? So I want to show you. So for finding the derivative of sine of x, we're going to use the definition. So first of all, we're going to define a function that is going to be sine of x. And then we're going to find f prime, which is the derivative. Now we know how to do that. We know that it's going to be the limit as h approaches 0 for the function sine of x plus h minus sine of x, I'm sorry, not h. And all of this divided by h, okay? So this is going to be our initial setup. I'm expecting that you know what this is and that you know how to find a limit. Now what I'm going to emphasize on is maybe the rules that you need to, well, not the rules, the trigonometric identities that you need to know. So I know sometimes it might be annoying to know that, oh, cosine of something is equal to cosine times sine times tangent. You have a lot of trig identities, but you only need to use one here, okay? So let me show you. Now we can take it as the limit as h approaches 0 for the function, and now we're gonna do something with sine of x plus h. When you have an input for sine that is a binomial, in this case you're adding, what you're gonna do is the following. You're gonna take sine of the first one, so sine of the first angle, sine of x, times cosine of the second angle, so h, plus, now you might see, if you know the differentiation rules, it's almost the same as if you were doing some rules, for example, the product rule, okay? You're going to take the derivative of one and then switch it, you know? So what I mean is that in this case, we took sine of x and then cosine of h. Now you're going to switch it. You're going to take cosine of x times sine of h minus sine of x, okay? And this big thing is just going to be divided by h. So now, what do we do here now? Now in this case, we have three terms, okay? Now, what you want to do in this case is you want to try to simplify it as much as possible. Now, we've got a sine of x here, and we've also got a sine of x in here. Now, what we're going to do is we're going to try to simplify or do something with both of them. And, well, we know they are separate terms, which means that we can factor sine of x out of them. And that would look something like this. So you're going to have the limit as h approaches 0 for the function, and now you can just simply take out sine of x. So sine of x, and now this times cosine of h minus 1, okay? Why minus 1? Well, remember, we need to get negative sine of x on this side, and if we multiply sine of x times negative 1, we're gonna get that, okay? And now plus cosine of x times sine of h. And now this entire thing, I'm gonna do something, and is that since we have h dividing this entire thing, we can distribute h because h is a denominator. So we can have in this case h, and down here h2. And now there is a property that allows us to simply find the limit of this big expression. I'm gonna do it in black. So to find the limit of this big expression, the only thing that we need to do is to find the limit for each separate term. So we can find the limit on this side and then the limit on this side and add them together and see what we get. So let's do that. So in this case, I'm gonna rewrite it up here. So we're gonna have the limit as h approaches 0 for, now this side, we have sine of x times cosine of h minus 1 over h plus the limit as h approaches 0 for this side. So we have cosine of x times sine of h, and this entire thing divided h, okay? So you get this. Now there is also another property of limits, and is that if you have, in this case, you could technically say that you have two variables in this expression. You have h and you have x. Now we care about h because for this limit we are saying that h is the variable that is getting closer to a specific number. So in this case we could consider sine of x and cosine of x as some sort of coefficients, or basically you can take them out of the limits because they are simply multiplying. So it would have the same effect as if you just simply said sine of x times the limit as h approaches 0 for just the part of cosine h minus 1 over h, okay? So this is what I mean. This entire thing is the same as sine of x times the limit as h approaches 0 for now the function that we do care about, cosine of h minus 1, and no parentheses here, minus 1 divided h, and now plus. Now you can do the same thing here with cosine of x, because cosine of x does not have h as an input. So you have cosine of x times the limit as h approaches 0 in the function sine of h over h, okay? Now I'm going to erase this part so we can have some more space. Now, what you can do right now for this part is you can just simply find the limits that you need to find. So, what is the limit for if, okay, so I'm going to write them here. So, what is the limit if we have h approaching to 0 for the function cosine of h minus 1 over h? Now, let's try solving this, just this part. Now, we know that cosine of 0 is going to be 1. So if we try to plug in 0 into this expression, the top should be, so I'm going to write approximately, it should be 1 minus 1 over, and now since we are technically saying that h is approaching 0, well, we're not technically plugging in 0 in here. I mean, we can plug in 0.00000001, okay? And well, if we have up here, let's say, 0.00, yeah, just 0001. This is just simply going to be 0 over this entire thing, okay? Whatever you have down there. And 0 divided any number is just simply going to be 0. So we know from this that this part right there, so this side, is going to be equal to 0. Okay, this part. So we have sine of x times 0. Sine of x times 0. And now in this case, now let's try to find the limit for this part right there. So I'm going to do it down here. So the limit as h approaches 0 for sine of h over h. Sine of h over h. Now how much is that? Now you may have seen a meme in, well, maybe in Twitter, for example, or maybe even in YouTube. And is that basically sine of any small number is going to be that small number. So sine of h, if h is a very small number, is just simply going to be h, okay? And now if we have h, so for example, you plug in any number h, so you're going to have h over, and now you also say that h is approaching 0, and it's going to be that same number that it's approaching on the top, so you basically have h over h, and this limit is just simply going to be 1, okay? So that means that this part right here is just simply going to be cosine of x times 1, okay? And so this allows us to get to the final part for this, for finding the derivative of sine of x. So we just simply get that f prime is just simply going to be sine of x times 0. Yeah, I should have placed the 0 before, but now I'm gonna use a parenthesis times 0 plus cosine of x times 1. And we know this is just simply equal to cosine of x, okay? And this is basically what we were looking for. Okay? Cosine of x is the derivative for sine of x. So I hope you guys enjoyed this video, learned something, maybe some things about limits. If you didn't know this property right there, that if you have something multiplying what you actually care about, the functions you care about for the limit, then you can take out that thing and multiply it as if it was a coefficient. Well, maybe you learned some trig identities too, maybe the trig identity that we use on this site. So well, I hope you guys enjoyed this video. It was pretty cool to find these limits. And well, see you in the following one.